Right, lesson 85. Should hopefully get them all done today. Out of 86. And it's page 528 and it's 19.3 Dynamics. Let me get that book open. Dynamics. That's page 528. Okay. Sorry about this. There we go. Right, dynamics is the study of forces in motion. From Newton's second law of motion, we know that if a force F newtons acts on an object of mass m kilograms, it will give it an acceleration of, and if it gives it an acceleration of a meters per second squared, then force is mass times acceleration. Okay, so I've had that several times before. We use this equation in chapter 18 to solve problems where the forces need to be resolved to in perpendicular directions. In this chapter, or chapter, we will recap resolving forces in 2 dimensions and then learn to use Newton's second law to solve more complicated problems. So example 1. 3 forces act on a particle of mass 4 kilograms positioned at the origin. Right, so we've got this one here. That's 4 kg there. The first is a force of 15 newtons and acts on an angle of 120 degrees to the positive x-axis. So that means you start measuring from here. This is 0 degrees. So there's 90. So 120 is up here. So that's 120 degrees. And what's that one? 15 newtons. This is the particle here. So the second one is 20 newtons and acts on an angle of 330. Well, all the way around is 360. So 330 is just below the axis there. And that's 20 newtons. 330. So I'll just put that as 30 degrees that way. Just put that there because it'll put people off. And then the third is of 30 newtons and acts in the direction of the positive x-axis. No, mine looks different from the book here. It's in the book. Let me just rip this one out. In the book, I think I've got a typo here. In the book, so it's 230. I'm just going to good job I saw that. I'll stick to the book one. I could have still done it without numbers, but 230. So 120, that's 180 degrees. So 230 is 50 that way. So it's 230, the difference there, 110. Okay, the third is 30 and acts in the direction of the positive x-axis. So that's 0 degrees. Find the magnitude and direction of the particle. Okay. I quite like doing these ones in the column vectors way. Right, so the first one that we talked about was the 15. So we can say, if you remember, we do the horizontal in the top of the column vector, the vertical second. If that's 30, if that's 120, that bit's 30. So horizontally, this is going to be minus 15 sine 30 degrees. And that's because this bit here, I'll do these in a different colour actually. Let's do these in red. The 15 is made up of that one and that one. And that bit there, that's 30. I'll just do that in red as well so that we can So that's this first one. Okay, so that makes a right angle there. So that's the opposite. So that gets the sine. And then this one is the adjacent. So vertically it's positive. This way is negative, that way is positive. Then up is positive and down is negative. So this is plus 15 cos 30 degrees. That's that first one there. The second one is this one here. So this one's negative, negative. And then that angle there was at 230, so that angle there is 50 degrees. I'll put that inside here. Okay, let's go back to blue. So this one, they're both negative. Horizontally, that's going to be 20 cos 50 degrees. And vertically, well, it's minus, and then minus 20 sine 50 degrees. So that's number 2. That's number 1. There's number 2. And then number 3, it's 30 horizontally, 0 vertically. So they're all the forces, and then that's equals to mass, which is 4 times acceleration. Is that what we need to do? I'm doing it slightly different from the book. We need to find the magnitude and direction of the acceleration of the particle. Magnitude and direction of the acceleration of the particle. Oh, a few typos in there. Okay. Yeah, so what I've put's right is going to find mass times acceleration. Right, so we can say calculator now. So I've got minus 15 sine 30 degrees. Minus 20, I'm doing the horizontal ones first of all. Cos 50 degrees plus 30 is 9.6. So acceleration. And then we've got to divide it by 4. 2.41. Yes. X is equals to 30 minus 15. I'll just check that again on the calculator. Minus 15 times sine 30 degrees. Minus 20 times cos 50 degrees. And then plus 30. 9.64. And then we've got to divide by 4. .41. Yep, so it's 2.41 horizontally, and then vertically 15 times cos 30 degrees minus 20 times sine 50 degrees, and then divide by 4, and that's minus 0.58 above two decimal places. Okay, and so we want the magnitude. It's going to be the square root 2.41 squared plus minus 0.58 squared. Square root of that answer, 2.48. Okay, and then the angle, it's 2.41 across, minus 0.58 down. So we do tan inverse, shift tan, 0.58 divided by 2.41. So it's 12.5. Got a different answer from those here. I've got angle 12.5 degrees below the horizontal. Okay. Okay. Just going to check something. Okay. Just going to check. I'm just checking some of my figures here. I don't know how to pause on this iPad, so just bear with me a little bit while I just check. I'm just checking this lot here. X minus 5 divided by 4. 15 cos 30 degrees minus 20 sine. It's this calculator. It's quite old-fashioned, I think. Divided by 4. Yep. Times 4. Okay. It's done. Yeah, so I'm happy with that one. Minus 0.58. I'm just checking these here. So I need to do tan inverse. Shift tan inverse. Open brackets 0.58 divided by 2.41. 13.5. Yeah, I never thought that was a typo. I think I'm blaming my calculator. It's because it's just slightly different. You have to do tan inverse 0.58 over 2.41, and it's 13.5 degrees below the horizontal. Okay, I don't know what my error was, but that's correct now. Right, example 2. A box of mass 60 is at rest on horizontal ground. 60 kg. So we've got the weight due to gravity. It says use G60 at the bottom there. So the weight is 60 times G, which is 600 newtons downwards. So we've got the normal reaction upwards. As soon as I see something like that, I don't need that there either. Okay. Right. A girl pulls a rope attached to the box that makes an angle of 35 degrees to the horizontal. So this is a pull, it might be a T. The coefficient of friction between the box and the floor is mu. So this is going to be friction, which is always mu times R. The girl is pulling with a force of 400 newtons, and that box accelerates with 3 meters per second squared. Find mu. Okay, so the first thing to remember is that this 400 newtons can be split into 2 forces, like so. Well, that is 400 cos 35 degrees, and this is 400 sine 35 degrees. Okay, so if we resolve vertically first of all, we've got R, and it's going to do net force is mass times acceleration. So vertically R plus 400 sine 35 degrees minus the 600 newtons equals 0. So R is going to be 600 minus 400 sine 35 degrees, 600 minus 400, careful with my calculator, times the sine 35 degrees. R is going to be 371 newtons. R is 370.569 newtons. There is more decimal place. I'll round it off later. I'll just put more than enough in for now, so that I can round it off later. Right. And then we look at horizontal. And we've got 400 cos 35 degrees minus mu r is equals to mass times acceleration, because it's moving horizontally. Mass is 60 and acceleration is 3. So both of these are net forces, mass times acceleration. Right, so we've got mu r, so I'm going to add that to each side, subtract that from each side. And you end up with mu r is 400 cos 35 degrees minus 180. And r, so mu is 400 cos 35 degrees minus 180, all divided by R, which is actually the answer on my calculator, so I'll keep it accurate. 370.569, etc., etc. And I'll keep it accurate till the end. So then I can do open brackets 400 cos 35 degrees minus 180 divided by answer 0.398, and it says to two significant figures, so it's 0.40 to two significant figures. Right, example 3. A particle A of mass 7 kg is connected to particle B of mass m by a light inextensible string. Particle A rests on a rough slope, inclined at 30 degrees to the horizontal. Okay, I've got the diagram in front of me as well in case I start wondering what it looks like, but I think I've got enough information here. So I've got particle A. So that one there, that's the 30 degrees. This is particle A. The string passes over a smooth pulley. Just do it up to there, and then I can just use this one to go around. That's not quite right. Right, so let's just do this here. Circle. Right, there we go. And we've got particle B here. Right, particle A is 7 kg, so that's going to go down there, 7g. And G is 9.81. 7 times 9.81. 68.67. Okay. Particle B, that's mass M, so we don't know what that one is. That's M times 9.81 downwards. Got a tension in the string there, which is going to be matched there. Particle B is released and accelerates downwards at 2 meters per second squared. So this friction is going to act downwards. Got a normal reaction there. Okay. And then this one is made up like this. they always have the same diagrams all the time, so, or slight variations. That one's 30 degrees there. So this side here, that there is 68.67 times cos 30 degrees. And that there is 68.67 times sine 30 degrees. I think that's everything there. Okay, calculate the mass. Okay, well, if we think about particle B, the net force is on, that's particle B, that's particle A. On B, we've got the mass times 9.81 minus T is mass times acceleration. So this is net force is mass times acceleration. Okay, so we're going to have mass times 9.81 minus m times 2 is T. So m is going to be T divided by 9.81 minus 2. So m is going to be T divided by 7.81. So we need to work out the T. And then we can go back and work out the mass of B. I'm just going to put this in a little box just to keep this to one side, so it's not really part of the diagram. So now we need to work out T. So we're going to look at particle A now. And we have, if we resolve perpendicular to the plane, we're going to have R is 68.67 cos 30. And that's because this upwards one here has to match this downwards one here. Okay, I've got my calculator. Cos 30 degrees. 59.46996, etc., etc. Okay, then if we resolve parallel to the plane, we're going to have T up the plane minus 68.67 sine 30 degrees, because that's a down the plane one, minus mu times R, and mu is 0.4, and R is 59.46996, etc., the one we just worked out. And that's going to be mass times acceleration for that particle. And that particle is 7. And the acceleration is 2. So we're going to have T is 14 plus 68.67 sine 30 is a half. I know that one already. Plus 0.4 times, and then this is the answer on the calculator. So I can just keep that accurate. That's what T is. So I've got the answer on the calculator times 0.4 plus 68.67 divided by 2 plus 14. T is 72.1229. .1229, etc., etc. So we'll go back to M. Let's put all those in a box as well. M, go back up here, look. M is T, which is the answer on the calculator, divided by 7.81. Divided by 7.81. 9.2 kilograms, and we can have 3 decimal places, 9.23 kilograms. Okay, I do like doing these. These are such, they're mathematically, they are fun for me anyway. I'm sure they are for you too. I hope they are. Right, example 4. I'll be sad when we get to a lesson 86 later today. But I'll move on. I'll, when I've got these done today, on Monday I'll start looking at the assignments, hopefully. I'm uploading the ones who've finished. But it's not the deadline. That's my plan for next week. Plan for this week is to get all these lessons done. Plan for next week is to start making sure everybody's managing the assignments properly. Anyway, particle A of mass 10 sits on a rough table. Start drawing. 10 kg. And is attached to one end of a light inextensible string, which passes over a smooth pulley at the end of the table, 3 meters from A. This is particle A. I'm going to rub out that 10 kg. I'll do it like this, because it gets a bit cluttered, the diagrams otherwise. So it's 10g downwards, which is 98. Because they're saying 9.8. 10 times 9.8, 98. Newtons downwards. So we're going to have a normal reaction as well. Then we've got a string, which goes here. Let's just do it. Oh, try and just do it as freehand. It's a bit easier on there. Okay. And then the other end, this is 3 meters. String passes over a smooth pulley fixed on the edge of the table 3 meters from A. The other end of the string is attached to particle B. That's particle A. This is particle B. Mass 5 kg. Which is 5g. That's going to be 49 newtons. Held in mid-air. Mass B is released from rest, and after 2 seconds, particle A reached the pulley. 2 seconds to get there. 2 seconds, that one reaches there. Using G is 9.8, show that the acceleration of the masses is 1.5 and the coefficient of friction is 0.27. Oh yeah, it's a rough table. So the friction is going to oppose the motion, so it's going to be going this way. We're going to have a tension in the string as well. I think that's everything. A quick check. Okay. Right, so let's start with particle. What do we need? Acceleration. Let's start with, I'm trying to think. Well, if we start with particle B, because there's not many forces on that one, but that will fit into this gap nicely. Particle B, 5g minus t, that's the net forces, equals mass 5 times acceleration. Okay, so we get 49 minus t is 5a. That's all we can do with that one, so that fits into that gap nicely. Right, particle A over here. We've got, let's look at the perpendicular to the table. We've got R is 98 because, look, the upwards equals the downwards. R minus 98 is 0 because there's no acceleration perpendicular to the table, so R has to be 98. Then if we go horizontal, T minus mu R, that is equals to mass times acceleration. Mass is 10a. Okay, R is 98, so T minus 98 mu is 10 times acceleration. have a little think about this one. So there are our equations. Let's think about particle A as well. We've got that the distance it travels is 3, the time is 2, acceleration is what we need, and it starts from rest, so u equals 0. So we're going to have s equals ut plus a half at squared. So 3, 0 times 2 plus a half times a times 2 squared. So 3 is 2a, a is 1.5 metres per second squared. So that consideration gets us the part A answer. The acceleration is 1.5 metres per second squared. So it's the Suvat equations. I'll just colour in. So in yellow, I've used all this. Along with u is 0. Okay, now that we've got that acceleration, I can substitute it into the equations that I've just written up for particle B and particle A. I've put 1.5 there. 1.5 there will get me work out t, because I'll have all numbers apart from t. 1.5 there, will have just worked out t, so I'll be able to work out mu. Okay, so for part B, A is 1.5, and the equation for particle B is what I'm going to use. 49 minus t is 5 times A, so it's 5 times 1.5. So 49 minus t is 7.5. So t is therefore 41.5 newtons. Okay, so let's go, I'll do this one, I like this. That one's there, that's come from that there. And it's this force and this force. Okay, 49 minus t, and then the acceleration, which was actually yellow, that previous one. So that's come from, matches it with that one. And then if we substitute into the particle A equations, which is this one here. And for that one I've used that force, that one, and that one actually, all those blue ones. So I'm going to put T. So I'm going to put T is 41.5, acceleration is 1.5 into the equation for particle A. So T minus 98 mu is 10 times 1.5, which is 15, and T is 41.5 minus 98 mu's is 15. So mu is going to be 41.5 minus 15 divided by 98. 41.5 minus 15 divided by 98, 0.27. Okay, so that's the particle. So let's just get this colouring in done nicely. That blue. Comes from that blue there. Something like this. So A is 1.5, that's still from the yellow. And then that's the green. It's a wrong shade of green there. So I confuse people. I'm going to do it. So we use the green answer and the yellow answer into the blue equation. Oh. That was the green equation. And one more of these. Florence, mass 55, parachutes from a helicopter. She falls vertically at 14, this is Florence, 14.7 metres per second. Once she opens a parachute, she experiences air resistance of magnitude 275 V newtons, where V metres per second is Florence's speed t seconds after she opens a parachute. Using G is 10 metres per second, show that dv dt, remember that's A, acceleration, the rate of change of velocity with time, is minus 5v minus 2, and hence find v in terms of t. Okay, so this one's a little bit different. So she's 55 kilograms, so it's 55g downwards, and g, 55g downwards, 55 times 10, it's 550 newtons. She falls vertically at 14 metres per second. So that means the velocity is 14.7 metres per second. Once she opens the parachute, she experiences air resistance of magnitude 275 V. So it's 275 V upwards. Okay. And that's it, isn't it? So what we've got here, net force is mass times acceleration. So net force is about 550 minus 275 V equals 55 times acceleration. Okay. Now, look, we're using dv by dt here. So 550 minus 275v equals 55 times dv by dt. Okay. So I'm going to divide both sides by 55. dv by dt, 550 divided by 55 is 10. 275 divided by 55 is 5. Okay, so this is a differential equation, which we haven't done for a while, but they do come back. So we can say dv dt 5, 2 minus v. So if we divide both sides by 2 minus v, I've deliberately left a big gap there, then integrate both sides with respect to t. You can think of those as cancelling out. And then this side, minus ln 2 minus v is the integral of 2 minus is the integral of 1 over 2 minus v, and it's 5t on that side, plus constant of integration. Okay, I want velocity, so when t equals 0, we've got that velocity is 14.7. t equals 0, v is 14.7. So therefore, minus ln, yeah, I don't like this because we've got 2 minus 14.7, and you can't take lns and negative numbers, equals c. So what I'm going to do is what I can do is, if I just go back a few steps here, you're allowed to do this in maths because I didn't do anything wrong as such. It's just it led to an incorrect. It's when I substituted I could see I was going to get ln of a negative number. If you remember the log graph, that's at 1. You can't have it. You can't have, if that's log x, you can't have x's less than or equals, you can't take log numbers less than or equals to 0. So what I'm going to do is take the minus outside the bracket here. If I multiply top and bottom here, oh no, I'm not taking the minus outside. Multiply top and bottom by minus 1. Minus 1 over v minus 2. Okay, because it's an equivalent fraction. Multiply that by minus 1, it becomes minus 1. Multiply this by minus 1, it becomes minus 2 plus v, which is v minus 2. dv goes the integral of 5 dt. So we've got minus ln v minus 2 equals 5t plus c. That's better. So we can say t equals 0 ln, v equals 14.7. So therefore minus ln 14.7 minus 2 equals 0 plus c. So therefore c is minus ln 12.7. Okay, so we end up with minus ln v minus 2 equals 5t minus ln 12.7. Okay, and we actually want to get, what do we need to show? Show that dv dt is minus 5v minus 2. Oh, I've done that bit there. There we are. I've done that first part. That bit's in blue. And I'm actually going on now to find v in terms of t. Is where I'm going now. V in terms of t. Right, so I need a v. I'm going to extra space. I'll just add a new page here. So I've got minus ln v minus 2 equals 5t minus ln 12.7. We need a v. I'm going to multiply both sides by minus 1. So get ln of v minus 2, ln 12.7 minus 5t. I'll collect the ln's together. V minus 2 minus ln 12.7 equals minus 5t. So ln v minus 2 over 12.7 is minus 5t. That's rules of logs. So v minus 2 over 12.7 is e to the minus 5t. Multiply both sides by 12.7 and then add 2 to each side. There we are. And that's the velocity. Okay, that completes that one.